This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
Project management. Project management is immensely important in the general management of a business. And first of all, what do we mean when we say or use the word project? Because we tend to use it automatically and correctly. But let's see some of the characteristics that would help us maybe identify a project. And the first thing is they usually have, it's non-routine, it's not part of your normal work. It's a special, there's a start and a finish. So you might have your ordinary work, doing your ordinary accounting job, but then you're given a project maybe to identify perhaps the best accounting software system, or finding the best course to send people on to improve their Excel skills or something of that sort. So you've got your ordinary work, and then you have this project which is special. As I say, it's got a start and an end, a finite life, and it's non-routine. Now, non-routine in particular should be flagging up some dangers. Non-routine implies you haven't done it before, or if you have, it's not something that you're very familiar with, and so there are dangers, there are risks simply because it is unusual. Sometimes the project is to do with something that nobody in the organisation has ever dealt with before, a very novel, very unique sort of challenge. So you can't even go to other people to seek maybe advice as to how they did it. And again, risk. Third, most projects of any size will eventually require a team of people, maybe drawn from all the departments who are affected maybe by the project. And these people come from different backgrounds, and they come with different priorities. They want different things out of the project. And so if you're thinking of an IT project, maybe perhaps the people in the accounting department want very good internal controls, lots of passwords and so on to make sure that it's very secure. People in sales want very different output from it in terms of maybe sales analyses and the information it holds about their customers. People in IT, in a way, maybe don't care very much what the software actually does, but what they want is a very up-to-date, fast machine using the latest technology and programming techniques and so on. So you've got the different priorities pulling in different ways, competing. Remember we talked about competing for resources was a source of conflict and potentially destructive conflict, as people almost jockey and almost use politics to get their own way. They will have different terminologies in terms of technical terms, and people maybe don't quite speak the same language, and different outlooks. People in accounting will be relatively sensitive maybe to prices and costs and so on, whereas maybe people in other departments couldn't care less what the costs are, as long as they get the project done very quickly and get everything they want. So again, there's a real danger that team members won't get on, that there'll be a real kind of conflict within that. And again, this is going to give rise to risk. And finally, usually or often no benefit until the project is completely finished. Usually half a project was not going to do anything for you. Once you've embarked on the project, if you're going to get any good out of it at all, you kind of have to finish it. You're kind of locked into it, finish it or write it off. So you're spending in the hope that the benefit is going to come out of the project at the end. So again, there is risk. And above all, I would warn people that what you have to take particular care over is the scope of the project. Scope is really talking about what is the project going to do. People talk about deliverables. What reports or information is this going to deliver at the end of the project implementation and so on. And if you're not careful, either the scope has not actually been properly decided up front, so people got this kind of very airy, fairy, fuzzy idea of what let's keep with IT systems, what the IT systems will deliver, And then as the project develops, they say, well, couldn't we do this? Couldn't we do that? Couldn't we do the third thing? And you find that then the project begins to grow, or maybe you have to scrap some of the work you've done and almost start again from the beginning. And scope, I think about all the things that go wrong with projects. It is project drift, really, where the scope, what's going to be accomplished by the project is not properly controlled. Projects are important in the strategy of a company. Remember when we talked about right at the start, a strategic plan, think of 5 years away, the long-term future of the organization. You can't do that in a one-off kind of jump. That long-term strategic plan is going to be broken down into a number of discrete projects. So if you're thinking we need to open in Europe, if that's your 5-year plan, then there'll be one kind of project about opening in France. Within that, there will be other steps to look at that we have to find. Where are we going to be having a warehouse in France? How are we going to recruit staff? How are we going to look after the logistics of delivery in France and so on? So the large overall strategic plan breaks down into a number of projects, which themselves can then break down into a number of smaller projects. And the great thing is that this makes it much more controllable and traceable. Each of these little projects will have a start date. They will have a duration and an end date, and we can keep watch on those. We know how they should fit in with other projects. There is no point in employing people in France if we haven't already got the offices and the factories set up in France and so on. There's going to be a particular sequence that we have to do it on. You can give each of these steps a budget, a cost. You can give each of these steps to one person. It's their responsibility. You go to that person if that part of the implementation, that part of the whole strategy has not been fulfilled. And we have well-defined outcomes. Again, one of the potential problems with projects or any large strategies is you keep piling in resources and you don't properly measure the success which is coming out of that. Not necessarily monetary success, but simply whether spending those resources has resulted in something which is of benefit to the organization. And it's very difficult to do that in a very large, complex strategy. Much easier if you've got small projects, each with its cost, each with its little list of defined benefits that we're trying to find. What are the stages of a project? And the stages of a project, well, first of all, I'll say that if you kind of Google project management, you come out with hundreds of results because there are lots and lots of companies which are, in the project business. And very often they have their own proprietary ways of saying, here's the way a project will actually take place. Sometimes even put their own names onto these different projects, steps. But by and large, this is what's going to happen. First of all, you have initial screening. Initiation and initial screening. So somebody always comes up with the idea of a project, shouldn't we open in Germany? Shouldn't we move or relocate our manufacturing from, let's say, England to the Czech Republic or whatever the project is going to be? And you can't take them all seriously all of the time. To carefully evaluate a project can be quite time-consuming and expensive. What we're doing here, really, with this initial screening, is getting rid of really the non-starters. Okay, the ones which appear to be just not worth taking any further for some reason. So that is basically what that is. And then we will come through with projects which look as though they might actually work. And the first thing, or it's certainly very early on, you should do a risk assessment. Because all projects, we're spending a lot of money, we're not really going to get any outcome of a benefit until we spent a lot of that money. We have to do a risk assessment. And the various outcomes of this risk assessment which we have, the one that CIMA likes is TARA. And TARA stands for basically the various things that you can do with the risks and do with the project when you perceive the risks here. And the first thing that you might do with a risk is to accept it. You look at a risk, and we know that just being in business is risky. Just selling something to a customer is risky because there's a risk that customer will not pay or will go into liquidation there. So the idea of doing business and making profits is inseparable from risks. So one of the things we'll be thinking of doing is that we are just going to accept it. We're just going to live with it. We think the risk is sufficiently of low impact that it won't cause us great disaster. The second thing that we might think of doing is to reduce the risk. So we see there's a risk, we don't like it very much, so we take steps to try to reduce it. So let's say we're putting an IT system in, and let's say we had 12 different places in our organization, let's say 12 different warehouses where we could have to computerize. A way in which you can reduce the risk is, instead of doing all 12 together, you do a pilot operation in one of them, and you get things working nicely there. You see whether or not the IT system is actually the suitable one. You perfect it there, you gain experience and expertise there, and then having it working in one, you should be able to spread it through the other 11 outlets in the organization with a much lower risk. So you reduce the risk. Next one is you abandon the project. That's actually the last one. I'll come back to the T in a moment. But you look at the risk and you say, if this goes wrong, this is just disaster. I'm not even going to go there. So you look at this project and you say the risks are just far too high for me to go into. So maybe you're thinking of opening in certain areas of the world. Maybe you're aware there's maybe great political unrest in those areas of the world. And you say, I'm not going to accept it. There's no way I can really reduce the risk there. I'll just not open in that country. And I'll look at it again maybe in 5 years, but I'm not going there now. And finally, there is transfer. You transfer the risk or share the risk. One way of doing it is insurance. That is transferring. Another way you can transfer risk is to employ subcontractors. So you're thinking, I want to develop a fancy new website. There's lots of really, really good kind of options available for users of the website, but it's really quite complex. I could do it myself, but I think actually that's a bit risky. What I'll do is I'll get a subcontractor to do it for me, and then if it doesn't work, I'm not going to pay the subcontractor. So it's a way of, I suppose it comes in with reducing, it's a way of kind of treating the risk in some way. So TARA, transfer, accept, reduce or abandon, is what you can do when you do your risk assessment. A business case, you must have a good business case in a number of different areas, but the prime one is probably cost versus benefit. Certainly in a profit-seeking organization, you'd be looking at the cost of the project, you'd be looking at maybe the extra revenue coming in when you do that. We'll see in a moment how this can be very unbalanced. Costs are pretty much easy to assess. They're up front, they're now. Benefits could be a long time in the future. Even if it's a non-profit seeking organization, if it's a hospital, for example, you're going to be spending money on a new MRI scanner, but there's going to be competing for those funds, competition, MRI scanner, new operating theatre, new ward, new research labs, whatever it's going to be. We need some way of ranking or distinguishing which project might be better. We need some way of trying to see, for this cost, this is the benefit. Then there's going to be a project plan. This is in detail, who's doing it, what are the various dates on accomplishing the different tasks in the project, when we're going to review progress and so on. Doing the project itself. Sometimes we'll do it internally, sometimes it will be subcontracted, sometimes it's going to be a mix of personnel. We have to monitor and control the project. We have to look at what's called project milestones. So a project milestone is like saying, well, in 3 months' time, we should have done this, this, and this. Let's pause and just see whether or not we've actually accomplished that. Is it keeping to costs and as well as time deadlines and so on? Is there anything we need to maybe adjust in the project plan? Do we need to maybe warn people that this project is going to be a month late or it's going to cost a little bit more? How are we going to manage it? And finally then, the thing should be finished and ready. We close it, we deliver it to the people who are going to really benefit and use the project, and it should be reviewed. And we'll talk about the different ways in which it can be reviewed. The project risk, which we talked about, the TARA thing here, transfer, avoid, reduce and accept, that we had. What is actually going to determine maybe the project risk? What are the variables in it? And first of all, there is really how well is the scope defined? So when we talk here about defined, we're really talking about the scope. So it could be very well defined, it could be really written down exactly what this project is going to achieve, exactly what kind of reports and outputs going to come from the IT system, or it could be really hazy, not well defined. So a project saying this purpose of this project is to improve inventory could mean anything. What do you mean by improving inventory? Does it mean you're going to keep less inventory? Or are you going to keep more inventory so you don't run out of it? Does it mean you're going to keep the inventory now in better refrigerated conditions so it's going to last longer? Are we going to increase the range of inventory we hold? Is that what you mean by improving inventory, or are we going to cut it down? I mean, what does improve inventory mean? And the chances are that if you just say we're going to improve inventory, people will have their own spins on it, and people will, some are going to be disappointed then at the end of this, and there's going to be a lot of unrest probably and disappointment. If, however, it's well defined, you say what we mean by improving inventory is to reduce the number of stockouts, the number of times we don't have inventory when a customer wants it. We want to reduce that down to, from 20% down to 5%, and we want to reduce the overall value of inventory that's held on average. We want to reduce that, by 25%. Then, you are very carefully defining what's happening. Nobody's under any illusions. Small or large, if you have a very small project just affecting one department, that's obviously less risky than the project which is affecting the whole organization. More shareholders, more stakeholders are going to be affected in the large project than in the small one. And then finally, how complex is it? Is it a very well-rehearsed routine sort of a project, just kind of putting in a simple accounting system? Or is it almost, state-of-the-art, cutting-edge sort of project that no one has done before, a complex organization? And what we're saying here is that all of these variables can move across this, but if you end up with a project, which has been, if you say, would you like to be in charge of this project? It's going to be very large, it's going to affect all of the organization, many stakeholders. It's really experimental, very exciting, but we're not quite sure what it's going to be doing. Then I suggest you try and say no to that project. Don't go anywhere close to it because it will fail. If, however, you're offered the opportunity to be the project manager of something which is really well defined, really crisp, where the amount of damage is going to be limited if it does mess up, and where it's fairly routine, then this is something where the risk is going to be much lower and your chance of success is going to be much higher. Now, I'm not trying to say in this that large projects are always bad. Sometimes, large projects affecting every part of the organization, affecting almost every stakeholder, are needed. Sometimes you will want to do a project which is really quite experimental, quite cutting edge, because you see, if this works, then I'm really going to leapfrog over what my competitors are doing, really win a lot of customers. So it's perfectly okay to be adventurous, I suppose, with projects, but it should never be, I think, be hazy. You should never accept, or an organization should never embark on spending money when it has not kind of pinned down pretty closely what the desired outcomes are from spending that money. And therefore the project should always be well defined. The business case, primarily cost benefit, and these are the ways it would normally be done. When people talk about evaluating a project in a kind of financial management type of paper, then net present value, discounted cash flow techniques are normally regarded as the best. So can we work out a net present value for this project? We know that there are then inferior ways of doing project appraisal. Payback and return on capital employed are simpler, but they don't take into account the fact which is present in projects is that you tend to spend money now and you don't get the benefit maybe for 3, 5, 10 years in the future. That's why the discounted cash flow, of which net present value is one technique, is better. We know that projecting into the future what the benefits are going to be is an element of estimation in there. I think it's important that people do their sensitivity analysis, say how far could our improvements fall by, our hope for improvements fall by, before the project turns out to be a bit of a waste of money. We'll be thinking of using forecasting techniques, expected value decision trees, and so on. So we might say, well, there's an 80% probability that the sales will go to this, only a 20% probability they will kind of go to that, and so on. And maybe we use these probability estimates as well, though very difficult to get those probabilities worked out. Costs, as I said, are usually easy to budget. Benefits are often very intangible. Benefits are in the future, and a lot of guesswork involved in them. And it's worth just seeing the type of benefits which can be recognized as being the potential benefits of a project. First of all, you can have observable benefits, and essentially observable benefits are benefits which were not anticipated, but in retrospect we see that the benefit was there. So it's a bit like putting in a new accounting system, and then when it's in, you find that everyone in the accounting department seems a bit more cheerful, the morale is higher. And morale is higher because they're getting their work done more easily, and the machine is very reliable. They never have to re-input stuff because of a crash. And we didn't anticipate, or we certainly didn't evaluate better morale, but it's nice to have. So that's good, but it's no good at all when you're doing your cost-benefit analysis, because we don't even anticipate it, and it's going to be anyway notoriously difficult to put any sort of quantification on. Measurable means we can quantify it, but we can't anticipate it. So we could change our inventory. We hope that maybe better inventory is going to lead to better sales, but we've no idea how to predict what the better sales might be. But obviously you can measure the better sales. So sales this year were 10,000, sales next year were 12,000. the difference is essentially the inventory system we put in. Maybe we could say, well, we could measure the impact of this inventory system in terms of the 2,000 extra sales which we've made. But we didn't feel able to predict it. Quantifiable is where it's measurable and predictable. Now, this is where, really for the first time, we begin to get useful information for the cost-benefit analysis. So we say to ourselves, we have some evidence of some sort that we put in this new IT system, then the volume of sales will increase by 20% from 10,000 units to 12,000 units. And of course, once you're in the quantifiable area here, predicting the improvement, then it's a relatively short step to turn that quantity of sales into extra revenue. And this is where you really need to be for things like your net present value calculations, your cost versus your quantified financial benefits. A lot of work is put in here. We know this is kind of, out of court really, these unexpected benefits here. But anything we can do to turn a measurable benefit, to be able to anticipate it properly, to turn it into a quantifiable benefit is going to be worthwhile. And the sort of things that people would do is maybe run a pilot operation. So as we said, we had these 12 outlets. One of the ways in which you can reduce the risk is to say, right, I'll put this project into one of these outlets, and you can measure how sales have increased in this one outlet. And if sales have increased 20% in one outlet, then it's probably a reasonable assumption that they would increase 20% in all of the outlets, and therefore we can effectively turn the measurable benefit into a quantifiable benefit, which we can use to evaluate maybe the extending the project to all of these outlets. Sometimes suppliers will take you to reference sites. They take you to an existing client, and of course this existing client will swear blind that this is increased their sales by 20%. Be a little skeptical about that. The supplier is not going to ever take you to one of their clients who's unhappy with it and so on. Sometimes you are nearly forced into doing certain projects because you see, well, those competitors seem to be doing very well, and they're handling their inventory like this, or they put in a web trading type of interface. If we don't do it, we're going to lose out. It's good for them, it must be good for us. Sometimes I think it has to be said that these benefits here is really kind of done on faith and hope. Somebody else is doing it, they're doing well, we have to do it, we have to have faith and optimism that it will do the same for us, even though maybe we haven't gone and got a particularly satisfactory analysis in terms of hard cash. The project initiation document is important. Project initiation document suffers from its name, I think, here. People see the word initiation and they think it's only used at the start of the project. But really you need to think of the project initiation document as the key reference document and almost handbook of the project. Anything you need to find out about the project should be written in this document. So I'll answer the big questions here. What is the project? What's it going to do? What's it going to accomplish? What are the deliverables? Precisely what's it going to do? Why are we doing it? What's the financial justification for doing it? Who's going to do it? Who's a project manager? Who's a project team? Are we going to get outside project managers coming in to be change agents and so on to help us with that project? How are we going to do it? All internally, shared, all subcontracted? When's it going to be done by? So all these big kind of questions, how much is it going to cost and so on, are going to be pinned down in this project initiation document and should be pinned down as far as possible before the project starts. Because again, if you begin a project before pinning this down, then this is when project drift begins coming in, projects really begin going astray. So here's all the things which are to be found in this project initiation document. A very important person in the project implementation is the project manager. This often very difficult to get a good project manager because you need such a fantastic range of skills here. Remember, we said one of the characteristics of a project is often you're bringing people in from different departments. They've never worked together before. They've got different technical backgrounds, different priorities, different personalities. And you have to bring these maybe 6 people together, and you have to get them into an enthusiastic, motivated team, all working for the same thing. And you have to be able to try to get round any kind of conflict and aggression that there might be within that team. You have to have technical ability in actually running the projects. So you need technical ability in keeping track of the costs, keeping track of the time, maybe shuffling stuff around if something is slightly late, and so on. And also, ideally, you need technical ability in the subject matter. So if you're putting in an IT project, ideally your project manager does know a fair bit about IT and knows maybe the risks and dangers and how to talk to the various people involved in that project. You need to negotiate. You need to negotiate with the sponsors, people who are paying. For example, when you might need to negotiate is if a project's going to go behind time a little bit. You have to say, well, is it okay if we're late? Maybe you have to negotiate because maybe it was under budgeted. You've found some difficulties that weren't anticipated, and even the best organized projects are going to have some little problems within them. You have to maybe negotiate with your project team members, the people doing the work for you. Maybe negotiate with them to work a bit of overtime or come in at a weekend to try to get the project back on track. We need to be able to report and deliver and present how the project is getting on. You have to be willing to admit the bad news sometimes, if that's what the project sponsors need to know. You have to be able to, not flap around in a bit of a crisis, to be able to stay calm, work out logically, because of this difficulty, this is really what we should do. Communicating both to project team members and outside is very, very important. And to delegate. Project manager mustn't try to do everything himself or herself. You have to delegate to project team managers. You have to delegate maybe sometimes to outside suppliers. You have to stay away from them as they're doing their job, not keep kind of interfering with them. And say, right, I'll come back in 2 weeks' time, we'll have a chat and we'll review progress and we'll see how it's getting on. You can't keep hovering over them all the time and hoping them to perform well. So it's a very rare kind of set of skills perhaps to find all together in one person, and project managers are kind of worth their weight in gold. The project team, we've talked about teams and committees. A project team is a group of people with a set of complementary skills to complete the task of project. So an IT project will have somebody from accounting, somebody from IT, maybe somebody from sales, maybe somebody from manufacturing, because they're all going to be affected or have some input into that project. We don't want them to be too many people there, say fairly small. Maybe kind of order of magnitude, maybe about 9 people. Much less than that, maybe you're not going to have the right mix of skills. You're not going to be representative. Much more than that, you're going to have far too many people sitting around a table. Remember that the time costs money, but also, do you really need them? It's going to maybe delay matters, a lot of discussion that's maybe not needed, and so on. And we also, if you remember back to old Belbin, where we need a right mix of personalities, the shapers, the plants, the chairman, the resource investigators and so on. So we have a good mix of personality types, completer finishers, that will help the project to really accomplish what it's supposed to accomplish. The variables that the project manager needs to keep an eye on are as follows. And we've talked about scope. You need to watch scope really carefully, that it doesn't begin drifting, that random bits are not kind of added on to the project outcomes. There's also the time. We want the project to be done by a certain date. There's a cost. People have given a budget allocation to that. And then there is a quality. We want the outcome of the project to be of sufficiently good quality. Now, really the diagram is saying you've got these four things to balance here. And in any given project, one of these can kind of muscle its way in. So if, let's say, the project is to change your IT system because the government has brought in a very complicated new system of income tax for your employees, and this system of income tax must be implemented by the 1st of January. And if it's not implemented by the 1st of January, then you can't pay your employees. Now there, fairly automatically, I think you can see time is going to muscle in. Time is going to be the thing everyone has their eyes on. We have to be able to pay the employees on the 1st of January and so on. And if everyone has got their eyes on hitting the deadline, then the other things can go astray a little bit. So one way in which you can hit your time deadline is to throw money at the project. Get in more consultants, pay people more overtime. Another way you could do it is maybe to say, right, you can have the basic pay working for the 1st of January, but you can't have certain other reports being produced. So what happens, what's affected is the scope is limited a little bit. Or maybe what you do is to say, to hit those time deadlines, I won't do as much testing of the software. Of course, I don't recommend that. But you might have to go and say, right, we have to get the time, and maybe then you have to go to the project sponsors, go to the people affected and say, look, will you pay more, or would you rather have the scope limited a little bit? How are we going to make sure we get the cost to where it should be? I beg the time to deadline met. In other projects, it might be the cost. You're told that the cost of this project can be $250,000. On no circumstances whatsoever can it be over $250,000. So you're kept to this cost. And of course, the things that might suffer is the scope. You cut bits out of it. It's the time, because you let it take longer. You refuse to pay people overtime. You refuse to get new staff in, so it just drags on. And of course, there's the quality. One way in which you keep the cost down is by maybe employing worse people, or not going through all the testing processes and so on. So the project manager, as I say, are kind of keeping these balanced here. One may be the most important, but you mustn't kind of abandon the other ones because they are also important as well. Now, by and large, accountants have no problems keeping track of their cost. So what you can do is you can have timesheets, and people can allocate their time to work on the project. If you're buying equipment and materials, you can have a special little kind of a coding mechanism. You put the project code on it, so you know what the cost of the material or the equipment is going into that. Keeping track of the time is a little bit more complicated, however. And let's see the way in which you can keep track of time and make sure that the project is going to come in on time so far as you can. Now this looks very complicated. It's the same one as set out in your notes, but we'll just kind of talk through it. Talk through certainly the simple approach to it here. And this is a project which is to do with building a house. And what we've done is the project has been broken down into what are called activities. And activities is the A, B, C, D, E, F, G. Okay. So 7 activities in there, 7 things to do, stages, if you like, of building a house. And the numbers coming after them, A2, means that's taking 2 days or 2 weeks. It doesn't matter what it is. The B is taking 6 days or 6 weeks. Let's call it weeks. Okay. The 1, 2, 3 in here in the circles, don't worry about those. Those are just labels. Okay, just a label where you've got to in the project. And to make it live a little bit, we have to actually say what these activities are going to be. Okay. And let's say that A here, this is for your house, putting in the foundations. So you dig trenches in the ground and you fill the trenches with cement, concrete, you let it set. This is the base on which the house is going to sit. And we'll say B then is going to be the brickwork. Now the way this has been drawn, this is saying that first you do the foundations, and only after you've done the foundations, you've got the 2 here, can you go and do the bricks. It has to be in that order, it has to be in sequence. Okay. But we're saying there's another activity we can be doing at the same time as we're doing the foundations, and we'll say that this is make. I'll say make the woodwork. Okay. Now, the sorts of woodwork I'm thinking of, and this can be done in a factory, off-site. Doesn't have to be done at the building site. But what we're going to be doing is we're going to be asking a factory to make the window frames, to make the doors and the door frames, and also to make the roof trusses. The woodwork is going to be on the roof eventually. So making the doors, making the windows, making the roof woodwork can all start immediately. It doesn't depend on us having the foundations in, or it can be done in parallel. It can be done at the same time as these. And it's going to take 4 weeks. And then when we have at point 3 here, we have foundations, and we have like the shell of the house, the bricks are there and so on, and we have the woodwork ready to fit. So what we will do here is I'll say that 3 here, this is the roof beams. So we've got the bricks up. What we're going to do is put the roof on top, the roof beams on top of that brickwork here. And also what we have is the bricks are up, but there's kind of holes been left in the walls and so on, where we can put in the windows and the doors. So I'll put here W plus D, windows plus doors fitted. So our woodwork has been done in this joinery factory, and now we're using the woodwork to put the roof beams on the top of the bricks and the windows and doors in the holes in the bricks. And then F, this is putting the roof covering on. So it depends where you live. It's going to be tiles or slates or some sort of roof covering. So you have your wooden beams on here, and now we're putting the waterproof kind of covering on top of those wood beams here. And of course, you had to have the roof beams on before you could put the roof covering on, because they're going to support the tiles on the roof. And now we have basically a waterproof building. We have the roof on, we have the windows in, we have the doors in, and so on. And I'll say G here is things like the electric and maybe the plastering. There could be lots of internal works that can only really happen once the building has become watertight and secure. So this sets out all of the activities needed to build your house, but also sets out the order, the pattern in which they can be accomplished. And then what we're after is, well, how long is it going to take to build the house? What is the elapsed time to build a house? And one way you can do this, a simple way you can do this for smallish projects, is to go through all of the pathways through the network and work out their duration. So if we just go all along the top here, we've got A, B, E, F, G. Okay, and they have to be done one after the other. Foundation, brick, and roof beams, and roof, and then electrics. They have to be in sequence. So this is going to stack up to 2 plus 6 plus 3 plus 4 plus 6 out here. This is going to give you 21. And then you go through the next one. So instead of going like that, we're going to go A, B, D, G. So 2, 6, 8, 9, 10, going to be 16. And then we can go another pathway, C, E, F, G, also 16. And the last pathway is kind of straight through the bottom here. 4 plus 2 plus 6, giving us 12. And the A, B, E, F, G is the longest one here. This is what's called the critical path. And 21 is a critical path length. This is how long building the house is going to take. It cannot be done in less than 21 weeks because that time is kind of defined by adding up all the things that have to be done one after the other. Any activity which is on the critical path is known as a critical activity. And critical activity, you've got no freedom at all. If a critical activity took one more day, then building the house would take one more day because it's adding on to that time. And it's these critical activities that the project manager has to watch really carefully. They're going to be determining whether or not the deadline is going to be hit or not. Something which is not a critical activity, not on a critical path, there is more flexibility. So for example, making the woodwork here, well, we know it's going to take 2 days to put in the foundations. It's going to take 6 days to make the bricks. We've got 8 days there. It's kind of 8 days before we actually need the woodwork. The woodwork's only taking 4 days, so it's like a spare 4 days in there. We could take 6 days over doing the woodwork and it wouldn't make any difference. So we could not start doing the woodwork until day 4, and that would be fine as well. Similarly, in here we have some what's called slack really. This is taking 3 days, this is taking 4 days. So putting on the roof, putting on the roof covering takes 7 days. Sticking in the windows and doors only takes 2. We're not ready for the electrics and so on until we've done the 7 days worth of work on the roof beams. So there's no reason that we have to start doing the windows and doors immediately. We could kind of wait 5 days and then do the windows and doors on days 6 and 7. Or we could take 4 days over doing the windows and doors, have half the number of people doing it and let them take twice as long, but that would still be fine. So it would. And maybe what you can do sometimes is that, depending if the skills are interchangeable, if you see maybe putting on the roof beams is going a bit slower than you'd want, maybe you can take a joiner off doing the windows and doors here and move that person across to helping with the roof beams. So it definitely takes only 3 days, and it won't really matter if putting in the windows and doors here takes 3 days instead of 2 days. So as a method of planning, these network analysis or critical path analysis is universally used really in project management. It used in stuff like buildings, constructing buildings, shipbuilding, aircraft building and so on. Anything where there's a lot of complex processes going on. Another take on that is a Gantt chart. This is a revamp really of the diagram we had before. So these two are part of the same thing really. So if you look at A and C here, they have to start together. and then B is kind of tagged onto A. So if we look at this here, we have A and B, A and C starting together. One takes 2, one takes 4, and then we have these 6 here added onto this, which brings us up to kind of 8. And there's the 4 days. These sometimes are shown by dotted lines. Those are the 4 days around which we can kind of shift this C here, this making of the windows and doors. There's a bit of kind of spare there. And similarly in here, I think I've left out some of these blue bits here and so on here. But here I think we can see there's maybe a bit of a day there, which is going to be maybe a little bit flexible there. If we didn't start D there immediately, D here, then that's going to be fine as well. So a Gantt chart is another way, and it often shows where you have particular bits of flexibility which can be used. Now, you will understand, of course, that when predicting how long it's going to take to put up bricks in a house, that we're not absolutely sure. For example, it's a bit weather dependent, and it may take longer than we actually think. There's always going to be, in nearly every activity of a project, there's going to be a little bit of uncertainty about how long the project is going to take. And the standard technique for dealing with this is to use PERT, which means Program Evaluation and Review Technique, which builds in some of the uncertainty to the project durations, the activity durations. And what it does, it takes the shortest estimate, what's the fastest time you can do the activity. It's most likely 4 times that, and then the longest time. And of course we've got 6 estimates in there. Shortest, the 4 most likely, and then the longest. You got 6 kind of components in there, and you take the activity time as a kind of average of those. Okay. So if we had here, let's say that what we've put onto this at the minute is for brickwork 6. Let's think we think that's the best one there. So not the best one, but the most likely. So we think probably it's going to take 6. So we have 4 of them. Shortest time, we'll say, well, that's going to be very difficult indeed to actually knock a day off that, and it's never going to be less than really 5. People can't work any harder than that. But let's say we had a spell of really bad wet weather where we couldn't really be laying the bricks very well because the concrete and water would be kind of washed away. And let's say we had a spell of really bad weather, maybe that's 6. Well, maybe it would actually go up to 12. Maybe it could actually double in a really bad scenario. So what we have in here, 6 4s 24. Another 12 added on to that is going to be 36. 41 over 6. Okay. So we're coming out there to just a little bit less than 7 days for that. So we're going to be coming in at about around 6.9 or something of that sort, aren't we? So what we would do, instead of putting 6 days in there on the critical path analysis, you put 7 in there. What it allows you to do is to just move that estimate around a little bit, taking into account, probably particularly taking into account longest worst case